Okay, so hopefully you've attempted tangent of 135 and 240. Now we can check our work. So tangent of 135, okay, we're on the unit circle. Again, sine over cosine. So I'm going to do it up here. Tangent of 135. My sine is my y value, radical 2 over 2, over my cosine, which is negative radical 2 over 2. If we keep our numerator, change the multiplication, and flip, the radical 2's cancel, the 2's cancel, and we're left with just a negative 1. Okay, so tangent of 135 will be negative 1. And tangent of 240 is right here. Sine over cosine. We keep, we change, we flip. Negatives will cancel, 2's will cancel, and we get radical 3. These should be the same values you would get doing it the original way we were taught. Okay, it should be the same values of the chart that we saw yesterday. It's just from a different perspective. Okay, so the last thing we have to talk about is something called radian measure. Now, radian measure is found in 13-3, so we're starting with 13-3. And basically, it's just another unit of measure for our angles. So we've been very used to working with degrees, right? Degrees is the mode your calculator, you would have to put your calculator into degree mode to get degrees. Your calculator is actually in radian mode when it is reset. Okay, so what is a radian? Well, a radian is the angle made when the radius is wrapped around the circle. Well, what does that mean? Well, you see this radius right here. That exact length is basically extended up this way and then wrapped along the edge of the circle. So if I was to straighten out this side right here, it should be the same length as the radius. Okay, so now what is this equivalent to when we talk about degrees? Well, 1 radian is about 57.2958 degrees, and we'll talk about why that is the case. But you will rarely see 1 radian, 2 radian, 3 radian. When we talk about radians, you will typically see things in terms of pi, okay? And that's because these radians are going to be irrational values, okay? So a hint that we're working in radian measure is that you will see a pi, or you will not see a degree symbol, okay? So let's convert. Well, in order to be able to understand degrees versus radians, we should be able to convert between them. So there's a conversion factor. It's either going to be pi over 180 or 180 over pi. If we are going from degrees to radians, we multiply by pi over 180. A way to remember that is that I want a pi in my numerator. So the conversion factor has to have pi in the numerator. When I'm going from radians to degrees, remember I want to eliminate the pi. So we'll multiply by 180 over pi. So let's test this out. How do I convert 45 degrees into radians? Well, degrees into radians, I'm multiplying by pi over 180. Now, the way we represent our radians is we reduce the coefficients as much as we can, and we leave it in terms of pi, similar to over here. So 45 over 180 is the technical coefficient. Well, what is that reduced? It's reduced to 1/4 pi. Now, we typically don't represent it as a number times pi. Instead, we keep the pi in the numerator with the coefficient in front. So we would represent this one not as 45 over 180 times pi, but 45 pi over 180. Okay, let's try 38. Degrees to radians, we want to put a pi in our numerator. Okay, we are going to reduce 38 over 180 and it reduces down to 19 pi over 90. Remember, in your calculator, if you type in 38 over 180 and press math frac, it should reduce it down for you. And 89 times pi over 180. 89 over 180 does not reduce, so the final answer for this is 89 pi over 180. Okay, so now we have to be able to go in the other direction, right? Pi over 3 radians. How do we convert that? Well, remember, degrees will not have a pi in it, so the conversion factor has to be set up so that the pi's cancel. Okay, so when converting from radians to degrees, we multiply by 180 over pi. You will see that these two cancel, and then we take 180 divided by 3, right? 180 over 3. That gives me 60. So pi over 3 is equal to 60 degrees. Let's try pi over 9. To convert from radians, we multiply by 180 over pi because we want the pi's to cancel. And then we have 180 divided by 9 is 20 degrees. And last but not least, 2 pi over 5. Again, we're converting where we want the pi's to cancel. Okay, so now when I do this multiplication, right, I'm going to do 2 times 180, because that's my numerator, to get 360 over 5, and divide that to its most reduced form, and we get 72 degrees. Okay, so that's the basic way we're going to convert from degrees to radians. Now, how does this connect to the unit circle? Why are these in the same lesson? Well, remember everything we did on the unit circle with degrees? It's going to work out to be the same exact thing if our angles are measured in radians. Okay, well, what do I mean? Well, let's take a look at this unit circle. Okay, these are all the important angles that we talked about when we talked about the unit circle, right? They're all the ones that have 30, 45, and 60 as their reference angle. I want you to take the time to convert all of these to radians. So we're going to do the first quadrant for you just so you can see what to do. So I want to convert 30 into radians. So I'm going to multiply by pi over 180. 30 over 180 reduces to 1/6, so this is equal to pi over 6. So everything that is true about sine of 30, cosine 30, tangent of 30 will be true of sine of pi over 6, cosine of pi over 6, and tangent of pi over 6. They're equivalent, okay? They just have different representations, okay? So let's do 45. I think we already converted that in the last one, but it's okay. We want to convert 45 over 180. That reduces to 1/4, so we get pi over 4. And we'll put that there. And last but not least, 60 is going to be pi over 180. And 60 over 180 reduces down to pi over 3. Okay, now 0, if we multiply 0 by pi over 180, we know that's still 0, so we can leave that there. 90, right, we just continue. And we get pi over 2. So pause the video and calculate the rest of these angles. Okay, and when you're done calculating the rest of these angles, I want you to make a comparison between the intervals in degree for each quadrant versus the intervals in radian for each quadrant. So what do I mean? Well, in quadrant 1, we have all the angles between 0 and 90. In quadrant 1 with radians, that range is from 0 to pi over 2. Okay. Quadrant 2 has from 90 to 180. Find the corresponding values. Quadrant 3, 180 to 270. Find the corresponding. And quadrant 4 is 270 to 180. When you're done, unpause the video and proceed forward. Okay. So these are the values you should get, okay? So check your work, make sure you understand them, okay? So now let's finish with the intervals. Quadrant 1, we see goes from 0 to pi over 2, which is 90. Quadrant 2, well, it starts at pi over 2, but it goes to 180, which is equal to pi. Quadrant 3 goes from pi, which is 180, to 270, which is 3 pi over 2, right? And quadrant 4 goes from 3 pi over 2 to 2 pi. So that 360, that full rotation that we've been talking about this whole time, right, is going to be equivalent to 2 pi radians, okay? And that's a number you're going to want to remember, okay? All of these are numbers you're going to want to be able to recognize. So make yourself very familiar with these values, okay? So for your work, I'd like for you to fill in the unit circle completely, okay? I want you to have all the values together in one place. We want the degrees here, put the radians over here, and put the ordered pair here, which in this case would be radical 3 over 2 over 1/2. Please note that this is still cosine, comma, sine. So my cosine of pi over 6 is still going to be equal to the cosine of 30, which is radical 3 over 2. The sine of pi over 6 is going to be equal to the sine of 30, which is 1/2. So the second part of your homework is going to be filling out a table with all of these values so you have them in one big chart. Again, it's not to memorize, but it's so that you are very familiar with the numbers and what is